How's it going? My name is Chelsea Rivera, and this is the CAP 2 for Fate of Lactate for Kinesiology 516. So this is going to be the pathway between the muscles and skeleton and liver, also known as the Cori cycle or the lactic acid cycle. It occurs in anaerobic conditions, and we're going to start here where the muscle goes into where their glucose goes through something called glycolysis, where you'll need 2 ATP and it creates 2 pyruvates. And then normally the 2 pyruvates go into the citric acid and goes back around, pretty much what we talked about in our first cap. But when there's no oxygen available, we go through to the lactate. So the lactate goes through the blood system, which then becomes lactate to pyruvate back to glucose, and then it goes through the glucose, then goes through the blood system into your muscles again. So from glucose to pyruvate to our lactate is going to be what we call hydrolysis. Then through lactate to pyruvate back to glucose, it's going to be glucogenesis. These are very important in our muscles. Our body understands the formation of where we're going as far as knowing if we don't have enough oxygen, needs to go into the lactate acid, or if we have enough, then we would go through the citric acid cycle. And it just pretty much regenerates and keeps going that way. So this is right here is the replenishing. So as you can see here, the glycogen goes through, becomes the pyruvic acid, which you get a little bit ATP here. The pyruvic acid becomes the lactic acid, which then, like I mentioned, goes through the blood system, goes back into pyruvic acid, goes back to glucose, which then we get glycogen. And then you see here that the pyruvic acid can also go to the acetyl CoA, which is our citric acid cycle, produces ATP, and goes back through to glucose. So as I mentioned before, this is another last resort for energy because we're still producing a little bit of ATP during this Cori cycle. It pretty much, the lactic acid buys time so that the liver isn't taking the metabolic burden. And this occurs, so every time the muscle contracts, you're producing and using ATP, so we need to be able to regenerate more ATP, so that's why it continues to go through the glucose, back through the blood, back into your muscles. So just a continuing cycle that occurs so that we can make sure that we have enough energy for those high intensity workouts. So the effects on intensity and training adaptation. So as I mentioned, this does occur during high intensity exercise. It's when your muscular endurance increases. So the more oxygen you're using, the more lactate you're going to need, which creates more lactic acid. Another thing is your mitochondria increases in size and number, and oxygen deficient, so that is where the lactate comes into play. And then the recovery is key because when you're going from lactate, it is again going through the cycle, as I mentioned here, going through the cycle, getting back through the glucose into glycogen here, and it's creating those ATPs, which is the main energy source. So lactate versus lactic acid, many people want to say that they're same, but they do differ. As you can see here, lactic acid grabs onto the hydrogen here, whereas lactate does not. So the lactate is pretty much the leftovers from the lactic acid with the sodium and potassium adding on to that. It is the aftermath, so it's going to occur after lactic acid has produced. It does produce energy and it helps with exercise. The lactic acid is also known as the milk acid. It's, like I said, formed during the anaerobic glycolysis, and it's what releases the hydrogen ions. Oftentimes when you're working out and you're starting to feel that burning sensation, that's what the lactic acid is. And that's just your body telling you that you're kind of overdoing it, and it's getting to the point where your muscles are contracting. So when lactate can be used metabolically. So lactate is used when you're going from pyruvate into when you're at pyruvate and you're losing oxygen because of the high intensity level. That is when it's needed. Um, it is something that the body uses, and it's not just a waste product. Many people assume it is waste product, and it's not. It's a vital necessity. It helps with muscle glycogen production, and like I said, it gives more ATP as well. It may not be as much ATP, but it does give enough energy to help your muscles. Consequences of lactate accumulation. So it does create more hydrogen ions, which could potentially allow more acid built up, and that will make you more fatigued quicker. And the acid built up can also affect muscles, and where if you're, for instance, riding a bike uphill, you'll become more fatigued because that acid is building up, and then that could cause muscle cramps. So there is consequences of the lactate accumulating, um, but your body does pretty well at kind of evening it out and making sure that it tells you when you are overdoing it, and that's where you'll get those sharp muscle pains. These are my references, and I hope you enjoyed it. Thank you.